Hi everybody. Thank you all for clicking on this video. So let me start by introducing myself. My name is Rujul Krishna. I'm a third year computer science student at BITS Hyderabad. It's a private engineering college located in. Okay, that all that is not important. What I'll be talking about now is basically, first of all, let me talk about my purpose of being on YouTube. So this is a this pretty much a big learning curve for me also, and through teaching this subject and making videos, I can very clearly remember all these concepts when the exam time comes for myself. So that is my selfish purpose, if you'd like, but also like to spread this. To put out all this knowledge, all the notes that I have, which are basically belonging to my professor Nirman Ganguly sir. He is a wonderful professor. He has taught us really well, and so basically that is another reason to basically share this math knowledge that isn't very mainstream and isn't there are maybe no there are channels that make one or two videos about math and statistics as well. There was recently not recently, it has been a few months, but there was a video by Veritas Serum also, in which the host Derek Muller talks about Markov chains. So this subject like we will talk about Markov chains in uh, pretty much all the detail that is required, all the rigor that is needed, and we'll do problems as well. So this should, I guess, help a lot of people, and that also motivates me to make these videos. So what I'll be doing now is, okay, first let us talk about what are stochastic processes. It is written here, it is a random process. So before what is to understand what is a stochastic process, you need to understand a random process. But first of all, what is a process? So basically, a lot of events and a lot of things that happen in real life evolve with time. Things change with time, and sometimes sometimes you can think of them as completely random changes, but you can make maybe break down these changes into a couple of possible things that can happen and assign each one of them a certain probability. So a lot of things can happen, but some things are maybe more probable or less probable, and that is how the process is evolving with time. And basically, time is the most important thing here to understand what a process is. And the random variables that evolve with time are called uh, stochastic random variables. I think that I am correct here, but okay, we'll learn this much more accurately, much more precisely, and within the lectures. So okay, so the purpose is to construct predictive models and apply to real situations. So the name of the course should be pretty clear why it is what it is. Now I'll be going through the plan and basically what I'll be trying to teach in each lecture, not in each lecture, but uh, the overall path that we'll be taking to mastery of this subject. So first of all, the basic probability theory, like any thing that you would be covering in a basic first year or second year prob stat class, probability and statistics. So all that, random variables, the notion of expectation, what are generating functions, moment generating functions, as well as these limit theorems. For limit theorems, for example, the central limit theorem is a very popular theorem in statistics. I'll talk about that. So I'll talk about that in the lecture. I can make this video long, but okay. And then after we have got these basics, well, next we can move on to some other stochastic processes like okay, I'll intro. I mean, we'll discuss what a Poisson process is. These are all technical terms which are hard to understand. I mean, I completely understand. Nobody will be getting what all these things are, and the purpose of this video is not to uh, do that as well. Maybe some of you uh, can relate, and maybe some of you have a similar course and you are looking on YouTube for something similar. So I'm just showing you all what uh, this is, and you can accordingly align yourself with whether to watch my videos or not watch them, at least this playlist. So so again, this was some uh, processes, like, okay, so the Poisson process, and again other things related to the Poisson random variable. So to understand what is Poisson random variable, that will be, we'll discuss that in the topic of random variables itself. Why uh, these things are required to be discussed to move on to the next thing, which is which is renewal theory, Markov chains, and related things. So again, the purpose of this all these things are to study time evolving processes. So a Poisson process is a stochastic process, it evolves with time. A Markov chain is a stochastic process, it evolves with time. Renewal theory is also another more general version, but of a Poisson process, and it also studies stochastic processes, means those that evolve with time. So everything ends up evolving with time, and the probabilistic study of these and the models we use and all that we'll be discussing here. So after these things, the continuous time Markov chains are next on the agenda. So basically, when we study processes that evolve with time, we can either look at the process in like discrete intervals, like the 0th second, first second, second second, third second, fourth second. So in all these discrete moments, we could be looking at the process, or we could be uh, taking time to be continuous, and we could be looking at the 2.5 like second instant, we could be looking at the 3.7 second instant, and we could be looking at any uh, matlab, we could be looking at any like real value of time instant, if that makes sense. We'll be also discussing birth and death processes. All these are again the basics. Basic thing to keep in mind is just that it is a time evolving process. All of these processes are time evolving processes, and martingales as well. So again, martingale, stopping times, Azuma's inequality. All these are, I mean, completely go over the head for like beginners and so on. But again, these are things that are supposed to be learned incrementally, step by step. And to discuss these in the video here wouldn't make sense. And just the purpose of this video is just to show everyone that these things are there, and these things will be covered. Now again, so after the martingale section, we have the Brownian motion section. So Brownian motion is another type of random motion. The position of a particle evolves with time. It can be at a random place, and with certain assumptions we simplify the study. We uh, make a model for the Brownian motion, a stochastic model, and we basically try to probabilistically tell uh, probabilistically like describe the position of the model at like a certain time. So again, this will be only clear if you watch the videos that discuss these topics. Like the notes are like amazing that our professor prepares, and they're pretty easy to understand at all steps. So when I discuss these things in detail, that will I'm sure clear your doubts about what they are. They're just random processes evolving with time. That is all there is to this subject and this playlist. That is all. And so, again, like I said, the purpose of making these videos is to help me with all these exams. And right, so that is it for the handout discussion. And I'm really looking forward to like learning, teaching, and this whole process of putting myself out there on YouTube for like people to uh, learn from me. Kind of maybe I'm able to help them, maybe I'm not, maybe these videos are not that popular. I don't. This is the first time I'm making YouTube videos. Okay. I hope this helps me. I hope this helps you, and uh, that is all. And I will. I would like to request you to please watch the further videos, whichever topics you want to. You might need only certain topics. I showed you in this video what all we'll be covering, and you can accordingly very smartly decide what to watch, what not to watch. And so yeah, thank you all. Thank you.